Hello everyone, this is Siksha and welcome to the HFIP monthly seminar. Before we start, I'd like everybody to know that this meeting is being recorded. And because of NOAA CIO's recent protocol, we want you to please keep your cameras turned off and please don't ask questions until the end of the presentation. With that, have Youngsun joined yet?
Yes, I'm here.
You want to add something?
No, I'd like to welcome Jessica to give a presentation. This is very important presentation for the HFIP community to learn how the operational, the forecasts are being coordinated at the forecast office and then the National Weather Center. So welcome, Jessica. Thank you for agreeing to give a talk.
Yes, thank you very much, Youngsun, for inviting me, and to Siksha and to Jennifer for helping to organize this meeting today. I'm really excited to talk to you. I think that this is going to be a kind of a departure from what you're used to seeing at an HFIP meeting, but I think that hopefully it'll show how important the work you do is to the messages that get out to the public and to our partners to help them make decisions during tropical cyclone events. And perhaps it'll spur some conversation about the different things that can be done on the science and technology side, on the HFIP side, to help improve those products in the future. So my name is Jessica Schauer. I am the Tropical Services Program Manager for the Weather Service, which means that I'm in charge of weather service policy when it comes to products and services. So I work closely with the folks at NHC, but I also work closely with the folks at all the regional headquarters within the Weather Service, and they help make sure that their weather forecast offices are ready for the tropical season and have the tools that they need to get through a season. So these are the offices within the Weather Service that can issue tropical cyclone watches and warnings. So you can see there's quite a few in the Atlantic side, and then we also have in Southern California, San Diego, and Oxnard. And then out in Pacific region, we have Honolulu and American Samoa and WFO Guam. So these offices, all of them put out a hurricane local statement, which we'll talk about a little bit in a bit. But the East Coast offices and Gulf Coast also put out a tropical cyclone watch warning product and extreme wind warning products there and in Hawaii. And those products are only issued when we have Category 3 winds or higher that are expected. So it's almost like a tornado warning issued like with the polygon. And then all offices put out post-tropical cyclone reports that have a summary of the observations after the event, and that's usually available preliminarily about 5 days afterwards, and then we strive to have the a final version out 15 days afterwards, but it's continuously updated as you start getting more observations in after the event in many cases. So the way that the forecast is coordinated really differs with where you are within the Weather Service's area of responsibility. So in the Atlantic and in the Eastern North Pacific, NHC drives the forecast. So in these cases, NHC and the WFOs coordinate on the coastal wind watches and warnings, so your tropical storm and hurricane watches and warnings. And you see these on the cone graphic. So this is an example on the right. And you see the skinny lines along the coast that show like the hurricane warning in red, the tropical storm warning in blue, et cetera. And that watch and warning area has been coordinated usually now over a Google Meet by NHC with the WFOs to determine exactly where the longitudinal extent along the coast that they want those warnings to be. But what you don't see on that map are all the inland watches and warnings that the WFOs issue. So we'll talk a little bit more about that in a moment. But one of the key things I think that's important for modelers to understand about WFO operations is that the WFOs are tied to the official forecast from NHC. So if you're in a WFO on the East Coast or Gulf Coast, you really have to go with the NHC forecast. And NHC has come up with a new way to deliver that information to them in gridded form because if you're not aware, all Weather Service WFOs have to put out 2.5 kilometer gridded forecasts that go to the NDFD for a number of parameters, but wind and wind gusts are definitely among them. So the WFO issues those tropical wind grids and also tropical wind hazards. And when I say hazards, I mean watches and warnings. And NHC provides the official forecast for the wind. So they are tied to that forecast, and they need to make all their other parameters look like that forecast as well. So if you've got a situation where on day 5, you have an NHC forecast that's over southern Louisiana, and the GFS is in northern Florida, and the HWRF is up in Missouri, and the HMON somewhere out in the Gulf, they need to make sure that their forecast looks like the NHC forecast. And sometimes they don't have any model guidance that looks like that. So NHC has taken some steps to try to fix that, and so is the National Blended Model team. And I'm going to talk a little bit more about that in a moment. So how do the weather forecast offices get that NHC forecast into their grids? So there's an example here on the left of what we've been using all the way through the 2020 season, which is what's called the TCM wind tool. And if you see that small inset there, you can see a tropical cyclone TCM forecast from NHC. So if you've never looked at the text forecast before, this is what it looks like. And you can see the valid time of the forecast, and then the maximum intensity. The highlighted number here is 65 knots. And then you see the wind radii in the northeast, southeast, southwest, and northwest quadrants. And so the TCM wind tool was just a very simple tool that would take the maximum wind, so say 64 knots, or the 50 knot radii and a 34 knot, and graphically depict that everywhere within the quadrant. Now we know that NHC doesn't intend for a grid to look like this, for the strongest winds to lie everywhere within the forecast quadrants. So what was developed through Mark De Maria and Pablo Santos at the Miami WFO is this WTCM is what they call it. So it's a wind speed probability model TCM forecast. So this is what you're seeing on the right. So this is an example of a forecast that you can see goes over the ocean, and then over land, there's a wind reduction factor that's applied. And this is significantly different than the kind of information that we would get from that TCM wind tool, which would have slapped like the full, like say 64 knots of wind throughout a whole quadrant, like over land without any sort of wind reduction. Now, in the past, the WFOs have applied their own wind reduction factors to try to accommodate this, but this is a much more sophisticated way of providing the information. And then they get the official NHC forecast right from NHC. So this is what's going to start being used in the 2021 season. But with it also comes a few complications, and we'll talk a little bit more about those in a minute. So here's a look at Hurricane Sally from last year. And the WTCM has now been incorporated into the national blend of models. However, that's what you see on the right. So on the left is the WFO forecast. So it was using the TCM wind tool, and you can see that large area of the light green with the maximum winds covered quite a significant area there in the middle of the storm. It wasn't very representative of reality. And on the right is the WTCM forecast that is, seems to be much more physically realistic, and also has the wind reduction over land. And so on the right, the NBM which has the WTCM built into it. That national blend creates a background field, and it uses 35% of the HWRF forecast, 35% of the HMON forecast, and 30% of the blend, which, if you're not familiar with the national blend of models, it's basically like a super ensemble that is generated from global models across the United States. And a lot of the forecast offices use this as their starting point. So, but for tropical cyclones, we had some real problems, and I'll show you in a minute what I mean. with getting that background to blend with where the tropical cyclone forecast is from NHC. So whenever the WTCM is present, it's 100% of the forecast wherever there's 34 knot winds or higher. So what you're seeing on the right is that forecast. And in this case, what's available in the NBM right now does not have feature matching. And I'll talk about that in a moment, what I mean by feature matching. So this is an example of a tropical cyclone from last season. I can't remember which one right now, but you can see that up in the upper part of the main cyclone, there's like another, almost like another tropical cyclone. There it is, popping out. So when you have a blend that does not have feature matching for, like, say, the HWRF and the HMON, and then the blend background blend, you end up with these, two-eyed, three-eyed, tropical cyclones in the model, and obviously that's not realistic. So what the folks at the MDL at the Weather Service did was they've applied this new feature matching technique. So this is the new version of the blend, and still kind of working on this. This is still experimental and not in operations, but you see that at least now you don't get that extra eye that came out of the tropical cyclone in the previous example. Now, they're still working on this, and they've made a lot of progress over the years, but one thing that has prevented the Weather Service forecast offices from using it in operations is that it doesn't come out timely enough. If we want it to be based on the current forecast, there's basically just a very short window, a few hours of time where you get the forecast from NHC and able to ingest that into the national blended models, and it's just not quick enough turnaround time to be able to get it back out to the forecast offices before they need to put out their grids at the advisory time. So that's one of the struggles that we've been working on right now to get this information out in time. So next I wanted to talk a little bit more about watches and warnings and how NHC, and this is again Mark De Maria and Pablo Santos, who have been working on basically a tool that can recommend what kind of watches and warnings are needed and when to put them up for WFOs for their inland zones. So that area along the coast is coordinated between NHC and the field offices, and basically whatever's agreed there, NHC sends those forecast grids to them in Awips, which is our software that we use to put out forecasts to the WFOs. So those are fixed once they've come to agreement on that on the conference call. But then the WFOs are left to themselves to figure out where they want their inland watches and warnings, and they haven't really had any guidance specifically for that in the past. So what Pablo and Mark did was they took the WTCM that we were just looking at, and you can see an example on the right of a composite from Hurricane Michael of WTCM forecasts and the wind speed probability. So that's what you're seeing in the upper panel there. And with that, they've come up with an algorithm to help predict, as well as with logic, with, once you've raised a tropical storm watch, and you wouldn't want it to be going up and down, or, if you have a hurricane warning, you wouldn't want it to come down and then come back up again. So it has logic built into it to try to maintain consistency and to basically give some guidance to WFOs on what kind of hazard watch or warning they should be issuing. And so you can see here that this is actually something that the WFOs had asked for, because it's something that they don't have a lot of experience with. When you think about it, NHC has, they'll forecast for every storm in the Atlantic and the Eastern North Pacific, but the offices, aside from 2021, where we had so many landfalling storms, it's fairly rare for most offices to be issuing tropical have watches and warnings and tropical products. So anything that we can do to help them is good news. And this also is an example of facets. You can see how we're using probabilistic-based information to inform watches and warnings, which are basically messages to people to tell them to prepare or to act to avoid any damage to themselves or to their property or to their loved ones. So here's a little closer look at the components that go into the TC wind hazard recommender. You can see the WTCM information on the top and the hurricane or 64 knot wind speed probabilities and the 34 knot wind speed probabilities for tropical storm and hurricane hazards there. So that ends up all getting converted together into what this is a hazard grid, where you can see hurricane watches and warnings, as well as tropical storm watches and warnings across the parts of Florida, Georgia, and Alabama here. And you can see that the Weather Service zones, and if you're not familiar, the Weather Service breaks down areas geographically by zones. And these zones are typically map to counties, except for a lot of these in the Southeast, they've split them apart. So, for example, here in Miami-Dade County, where I used to live, where I work, there are 4 zones now for such a large area. So you've got your coastal northern portions of Miami-Dade and southern, and then your inland portions in there as well. So this has been done in a lot of the places along the coast to help differentiate coastal impacts from inland, more farther inland impacts, especially for storm surge, to kind of help differentiate. But you need to remember that when you get a forecast, like for a text forecast, it's generated based on like kind of a sampling through the entire zone. And we'll talk a little bit about how that affects the messaging that comes out in the text products in a few moments. So the TC Wind Hazard Recommender was the first experiment, used for the first experiment that was coordinated between the Hurricane Research Division at OML and the National Hurricane Center. They had their first ever hazardous weather testbed tropical cyclone experiment. And originally this was conceived as part of the FACETS program. There's a FACETS postdoc, Lacomarian Worku, who's been working with this. And originally the thought was that this was going to be an experiment that was done in Norman, Oklahoma, at the Hazardous Weather Testbeds physical facility. But of course, COVID happened. And so we had to come up with a way to have this experiment happen remotely. So it was a challenge to get it to work remotely, and it took a while to get things hired out, but we were able to get things to work between the forecast offices and NHC and they evaluated 2 different algorithms that had different weights for the wind speed probabilities in the WTCM. And this is a really, really important first step for the tropical program, for NHC, and for HRD, OAR, to kind of have some sort of experiment where, in this case, we were looking at something that's going to be used internally, and our customer base is the WFOs, and making sure that this works for them, and for them to be able to point out, what's good or not so great about these different algorithms, but also the communication part, how this is going to work into operations. We don't have anything like this now. So in order to be able to do this, in most cases for tropical products, we have to have some kind of live system. So to have something to be able to do to show how operations can be changing in the future, how we can improve things, and be able to do it in a laboratory experiment where we don't have to throw this out into operations without really having it tried and true, is really important. So the participants really noted that the need for more experiments like this, and in bringing up, we get new tools from folks like you, or new models. Like, how do we best evaluate how it's going to impact the messages that come out in our text products and in our graphical products? So there really is a big need for some kind of tropical testbed or operations proving ground. So here's an example of a future need. So I presented information about the WTCM and that wind reduction that we see. And the example on the left is the current operational wind speed probabilities. The example on the right is an example of the wind speed probabilities calculated using the WTCM for the 1,000 realizations. And as you see, it's a significant difference in what you see for the wind speed probabilities for, in this case, what tropical storm force winds. for a storm that's going to affect Florida like Dorian. So this is going to cause a significant change in what we would see in the in something like the TC wind hazard recommender that relies on the wind speed probabilities, as well as the operational products, which also rely on the TC wind speed probabilities. So here you see you got the inland wind reduction over Florida, and we need to determine how to account for that lessening of the wind speed probabilities over Florida before we can implement that into operations, so that we can adjust our algorithms that are sampling for our messaging that comes out of our products, which I'm going to talk a little bit more about now. So let's take a closer look. This is Coastal Bay County in Florida with Hurricane Michael. And the example on the left shows the TCM wind tool grids for wind. And so you can see the wind legend there on the right. The winds that are in green are less than 39 miles an hour, and it goes up to, in this case, the red, which is wind 74 to 110 miles an hour. And within that county, we have a text formatter that will sample all of the grids within that area, within that zone, so portion of the county. And so we need to determine, that will help determine what the message is going to be for that zone. Also, the Weather Service, if you've ever been to weather.gov, you can put in your zip code and get a forecast, or you can click on the map and get a forecast. And that's actually querying these grids to help come up with the messaging. Where if you clicked on that, where the arrow is in both of these graphics, you would get the wording hurricanes conditions possible, even though the winds are less than tropical storm force. And that's because you get it's taking both the deterministic wind that you're seeing here, as well as the wind speed probabilities to come up with that messaging to account for the uncertainty in the track of the storm. So, and even though you may be seeing a forecast that says that the winds are only expected to be, maybe 25 to 30 miles an hour, you'll see messaging that says hurricane conditions possible because of the wind speed probabilities. So the sampling over the whole zone goes into what we call the Tropical Cyclone Watch Warning Product, or the TCV. And the V is for VTech, which is something that you probably don't need to know much about, but it's basically the way that the alerts go to broadcasters or to like any push notifications that you get. It basically says there's a hurricane watch here. So and it's alerted by zones. So on the left is an example of what the messaging would be from a TCV product for that zone, Coastal Bay County, using the TCM wind tool, which had stronger winds in it. So you can see that the peak wind forecast is 55 to 70 miles an hour with gusts to 95 in that case. But using the WTCM, we actually see that the winds come down to 50 to 65 miles an hour with gusts to 90 miles an hour. So that doesn't seem like too much of a difference. And the potential threat to life and property, which is calculated by incorporating both the wind speed probabilities and the deterministic wind, ends up being the same in this case. However, we're not sure what's going to happen when we have the new wind speed probabilities that incorporate the inland wind reduction. How are we going to need to tweak the sampling here? Right now, we're using the 85th percentile to come up with the wording that you see for the latest local forecast. And the algorithm that incorporates the wind speed probabilities may need to be adjusted if we have the wind speed probabilities were to bring down that potential threat. Then it would change not only the text that you see here, you can see it for the TCM wind tool showed the potential for winds greater than 110 miles an hour. Now we're talking about bringing that down to the potential for the winds 74 to 110 miles an hour. And maybe that's appropriate, but there needs to be some kind of laboratory testing to be able to determine what the best way is to get the messaging through. Like should the algorithms, how much should they weight each one of these pieces of information? So that information goes into what I said, the VTech, which is the watches and warnings. NHC is able to collect all of the watches and warnings in the hazard grid from the WFOs and put it into a single product. It's here on the right that is mainly used by the media to help alert them. It shows them where all the watches and warnings are at one time. So we don't currently have a single graphic that does that, because the cone graphic would be pretty messy if we had all of that on there in addition to the cone. But that's something that we can explore in the future. So the watches and warnings aren't just wind that are included in the national TCV, it's also storm surge. And storm surge watches and warnings right now are only created for the East Coast and the Gulf Coast of the United States. And this is a really unique process for the Weather Service. What's done is NHC proposes where there should be a watch or a warning for storm surge. And they do that basically based on P-Surge, which is the storm surge model that runs based on the official forecast, or occasionally PETS, which is the which is a probabilistic ensemble that's using the GEFS to drive the forecast. So NHC has those two pieces of probabilistic information that they can use to help determine what their proposed grid is going to look like for storm surge watch or warning. Then the forecast office has a chance to take a look at it and apply their local expertise. Maybe they'll take away area here, add an area there, and then send it back to NHC. And if there's agreement, then they'll add that as the storm surge watch warning area. It'll match between what the WFO is putting out and what NHC is putting out. So when I mentioned ensembles for storm surge, I did that, obviously for a reason. We really don't want to use deterministic models for storm surge. I mean, here's a prime example. And this is from IRMA. And this is showing the 10% exceedance, which is what NHC calls the reasonable worst case scenario. And it's used to create their inundation graphic. And you see on the left, this is the 48-hour forecast, and the forecast going north of Cape Coral before it makes landfall. And on the right is the actual forecast, our actual best track. And you see that the storm surge amounts for like the Fort Myers area basically went from over 9 feet to actually blowing out and having less than storm surge basically being nothing. So we need to have ensembles when we're talking about storm surge. And if you see here, this is an example of what the P-Surge forecast kind of give you an idea of how it can vary the long track and the cross track timing of the storm, and to help give a more thorough input to what the storm surge potential is, help accommodate that uncertainty in there. And then the new version of P-Surge that's coming in May is actually going to use the NHC radius of maximum winds rather than assuming a relationship between central pressure and the size of the storm. So this is a big push forward for the storm surge program. So the storm surge hazard then, if you look on the left, is the storm surge watch warning graphic. This is essentially one of the qualifier for a watch or a warning is around the potential for around 3 feet of inundation, because this is what can knock someone basically off their feet. And so you see that the storm surge watch warning on the left lines up pretty well with the areas in orange and red on the map on the right, which is the storm surge threat graphic that comes from the WFOs, weather forecast offices. So if you look at the legend on the map on the right, you see that that's the potential for storm surge flooding that's greater than 3 feet or greater than 6 feet. In the area, like on the far north part in South Carolina, that is, you can see that area is in a watch, and that's because of timing. The graphic on the right shows you 72 hours of assessment of your threat. And so the watch period only goes out to 48 hours, and the warning period goes out 36 hours. So you can see that's why you only have a watch, because of the timing there in South Carolina. But the graphic on the right is created by the WFOs, and it's based on, in most cases, P-Surge, but it could also be based on PETS. but it needs to be based on an ensemble for them to be able to put out the forecast. So, and that was done purposefully to make sure that we don't have situations like what we saw with IRMA. So the message that comes out in the TCV, again, it's sampling over the whole zone for these cases. So it's been calibrated to accommodate the specifics there. You can see that it has a potential threat to life and property from flooding greater than 6 feet above the ground. And then the actual forecast also says about 4 to 7 feet above the ground. So we want people to prepare for the conditions that were forecasted. That shows that there's not a lot of uncertainty in the storm when you've got your forecast and your potential threat basically about the same. So it's the maximum grids are created, inundation max grids and inundation timing grids from PSURGE or PETS by the WFOs, and that helps calculate the values and the colors that you see on the maps. So in Awips, the WFOs have a display where they can see the different percentage chances of exceedance. So here's an example where you can see the 10, 20, 40, and 50% chances of exceedance. And they can vary what the messaging would be in their TCV by selecting the probability of exceedance there. As the system comes closer, they have the option to increase that probability of exceedance to something that's closer to a deterministic forecast. But in most cases, we use that 10% chance of exceedance because that is closer to what the NHC inundation graphic is based on, and because accommodating uncertainty in storm surge forecasts, it's really sensitive to very small changes in the track. So that 10% chance is valid, a lot of times even as the storm is approaching land. So again, the only options here are PSURGE and PETS. So that does cause some issues, especially with hybrid type storms that aren't very well formed, because PSURGE has really been based on an idealized vortex in the past, and now this new change in PSURGE hopefully will, where it depends on the NHC radius of maximum winds, will hopefully help that. So the hurricane threats and impacts graphics are created for wind, storm surge, flooding rain, and tornadoes. They're available on the website that you see here, but if you go to most weather forecast offices pages, it is usually available in the drop-down menu listed either as tropical or hurricane hazards. So you can find it that way as well. There's this threats and impacts tab that will take you to the map that is clickable. You can click anywhere on the map and get on the right, basically a parsed version of the TCV product that'll tell you the locations affected, the forecast, in this case it's wind, and then the window when the forecast is valid. And then when you click on the map, you get a list of potential impacts to be concerned about. So like in this case, considerable roof damage to sturdy buildings. So it helps communicate that degree of preparation that's needed. So the colors incorporate some kind of uncertainty in them. So in the storm surge, it's because it's an ensemble. On the wind, it's because it incorporates the wind speed probabilities from NHC in this case. And also for the flooding rain and tornadoes, that information comes from SPC or WPC. So here's a closer look at what the page gives you. And you can see that you've got basically what I'd already broken down, but you can see the what, where, when, how much, and the impact and hazard statements there. So here's a look from IRMA at all 4 graphics. And you can see that it has a list of like what's incorporated into those graphics. The WPC excessive rainfall outlook is used for the flooding rain, and the tornado threat comes from the SPC severe probabilities. And this is going out 3 days for these graphics. And it's one snapshot of what your threat is for each one of those hazards. So some other WFO products, the extreme wind warning I mentioned at the beginning, kind of hard to see, but you can see the polygon in the radar image on the right that basically it shows you where there's a threat of having category 3 winds or higher on land. And then on the right is an example of a cut example of a PSH product, which gives you the observational data from the storm. So there are some other WFO products. The Hurricane Local Statement, I think I mentioned right at the top, is the one product that's created by all of the WFOs that issue tropical watches and warnings. And you see here, this is an example of the flavor that's generated in the Atlantic WFOs and WFO Honolulu. And it's kind of another version of the Tropical Cyclone Public Advisory that you'd see from NHC. It's got that new information at the top with the watches and warnings and the position and the intensity. And then you have a situation overview. It's kind of free text. And then the wind surge and flooding rain information in this case, much of that is coming right from the grid. So the forecaster doesn't do a lot of manual edits here. That does have impact information in there, like, that would kind of give more information about what kind of impacts you can expect from the storm. And then precautionary and preparedness actions. So there are some slight differences for the offices in Southern California. Right now, they are not generating a TCV product. And so we're going to talk a little bit more about the differences between the HLS products that come out from Southern California now versus what they will in the future, which is what we just showed. Next year, Southern California is going to start creating the same HLS product that I just showed. But right now, they still are putting out the version that you see in Guam and American Samoa. And we will talk a little bit more about that in a minute. But a few other things coming for Southern California and for those Pacific offices. Hopefully, P-Surge plus waves, which is the storm surge specific guidance that the East Coast and the Gulf Coast has, but incorporates the wave run up and setup, which is really important in those locations. And so that's something that we're hoping that we can get going in those areas. They do already have moms and meows, for those of you who are familiar with that. And we will also talk about that more in a moment. And the national TCV, we're hoping to be able to compile that the same way we do for the Atlantic starting in 2023. But there's no digital collaboration right now. That would be the first kind of digital collaboration process. That and the TC Wind Hazard Recommender would also be coming for Southern California, hopefully around 2023. There is no plan to issue a storm surge watch or warning in Southern California. They didn't think that the conditions there really warranted after seeing the moms and meows, and there are other ways to get that message out. So this is the Hurricane Local Statement version for Southern California currently, and Guam and American Samoa. And you can see it's slightly different. It does include the newest information and the situation overview and precautionary preparedness actions, but more like the TCV, it breaks it down into zones so that you can get that specific forecast for each zone within the area. So I wanted to touch a little bit on Pacific region tropical operations, because this is where we have a lot of challenges, and because they are not, at least for WFO Guam and WSO American Samoa, they're not tied to an official forecast as much as the offices are that have the NHC forecast or the CPHC forecast for Hawaii to kind of dictate what's happening there. So the wind forecast is obviously you have to go with the official forecast, and that happens also at CPHC for the Honolulu forecast office. So you can see that highlighted there in red, their area of responsibility. And that's basically the same office, the folks at the Honolulu forecast office and CPHC. So they're kind of coordinating with themselves. Whereas the folks at American Samoa, their official regional specialized meteorological center for tropical cyclones is in Fiji, Nadi. So they have that forecast to look at. And likewise at Guam, they've got the RSMC is Tokyo. But they also have the Department of Defense's Joint Typhoon Warning Center forecast. And they are able to deviate slightly from these official forecasts for things that are more specific to their neck of the woods if they feel they need to. They obviously have 2 forecasts there to rely on from TC Forecast Centers. So that makes things a little bit more complicated, and it also means that they have more of a need for actual like hurricane models, wind models, and that's something that they would be more likely to look at than a mainland WFO. And they just this year they are starting to put out, or CPHC is creating these graphics based on JTWC forecasts that look just like the NHC and CPHC cone graphic, wind speed probabilities, and time of arrival graphics. So these are newly available new tools for decision support that those offices can use out in the Pacific. And you can see here, this is an example of the areas of responsibility for WFO Guam. It's a very large area of responsibility. And here, they have 39 breakpoint areas, which, you can tell that's something like in there. They actually put out a public advisory like a TC Forecast Center, but they don't put out a TCM. So they don't put out a forecast for a tropical cyclone. And, each one of these breakpoints, it has, very unique and varying vulnerabilities. They have steep mountainous terrain in some places. They also have atolls and low-lying islands. So that's something they have to keep in mind as they're considering, what kind of messaging to put out. Same with American Samoa. And, the residential dwellings across the region, they really range from reinforced concrete to just basically wood structures and lean-tos, and, how do they work with their emergency managers there to make sure everyone's prepared for the storm? That's some of the challenges that they need to think about. And just in the last 2 years, we've been able to get storm surge guidance for them. This is the maximum of maximums, which incorporates, so this is, for those of you who aren't familiar, this is slosh-based climatologies that can show the potential for the strongest or the highest amount of storm surge in an area. This is actually American Samoa, and as you can see, like if they had a Category 5 storm approaching from that southeast direction, moving slowly, that their airport there is one of the areas that would see the highest amounts of storm surge. So that's something to obviously be concerned about. So the MOMs are generally used for planning purposes. On the mainland, they've been used quite extensively to help determine evacuation zones. The MEOWs are each, if you look at the tool on the right, this is actually from HEREVAC, which is an emergency manager's tool from FEMA. And they can, each one of those pie pieces, they can select separately. So if they had a storm that was moving in like from the east, they can select just that east pie on the pie chart on the right, and you select the category of the storm, the forward speed, and it would give them a varied timing, cross track and long track of the storm coming from that direction with that intensity, and kind of give them a picture of what kind of storm surge they'd get. But they don't have P-surge, like a storm-specific model yet out there. There's some more challenges for Guam and American Samoa. Again, they don't have an official forecast center, so they kind of are in charge of their own wind grids in these cases. They have very complex terrain. It's not well resolved by the models. We don't have a lot of high resolution modeling out there right now. And there's no specific storm surge models for TC specific storm surge models for Guam, American Samoa, and for Hawaii, or for Southern California at this point. So we have the MOMs and MEOWs, but we don't have something that we can run that's based on the specific storm at that time. And again, and of course, they have limited observations way out there in Guam and American Samoa. There's no radar in American Samoa, and they're on the edge of Himawari 8. And they've got limited land and marine-based obs, and especially water level gauges, not something that they have. So the need really to have the models set up for these locations, especially for storm surge, is really that's something that we're starting to explore on the tropical program now, to be able to get the P-surge data to them and put it into an inundation graphic or some other usable form that they can deliver decision support services to their partners. And speaking of decision support, like all the forecast offices create briefing packages for their emergency managers to help make decisions about preparations for the storm. These are an example of what one may look like. Some of the slides may look like in there. Some of them have these slides available on their tropical pages. Some of them are just for the emergency managers only, but this is a little bit higher level of information than what's in the standard products. Talks about forecaster confidence here. There might be specifics in there about impacts, like the WFO in the Atlanta area, Peachtree City. They may talk, specifically about like the different kinds of pine trees that they have there and their likelihood to fall based on, how much rain they've gotten previously, et cetera. So they try to add some value to the forecast there. And then, getting near the end here, I just wanted to put in a plug for, there's quite a bit of social science that's going on right now on the tropical side. In fact, at noon today, there was a webinar, Eastern time, there was a webinar from Dr. Joe Ripberger. That's the one on the top right. There's a chance of what that is looking at numeracy and which is how people understand probabilities, both from weather service forecasters to emergency managers to the public. So it was a very interesting talk. So if you have a chance to go and look at the NUA library webinars, I'd highly recommend checking that out, or any of the work by Dr. Joe Ripberger. He's really done some fascinating stuff about communication of probabilities. And the projects that you see here highlighted in red are all funded through the Hurricane Harvey supplemental. And because of that, we have a responsibility in the tropical program to show how we're going to be using the recommendations of these projects in making improvements to our products and services. So that is something that is like a big force on my end of the tropical program right now, is determining how these social science projects are going to change the messaging, the wording, the visuals that you see from the weather service during a storm. And I stole this last slide, abbreviated, from Youngsun and Frank from the IHC, and just kind of tying this back to HFIP. Some of the pertinent key strategies, the improving probabilistic guidance, and we talked a lot about P-Surge here today, and graphical product improvements. There are things that we know that we need to talk more about. We know that EMs want our products and services earlier. We have these 9 social, behavioral, and economic sciences projects that are happening to help us determine best ways to talk about risk and uncertainty. And then we have the R2O enhancement. And this enhanced JHT capability that I talked about, the hazardous weather testbed experiment at NHC and the WFOs, and that working with HRD, that's a very first step towards that, and that is something that we desperately need. So with that, I'm going to wrap things up and pose a question to you on any thoughts that you have about how your research can address some of these local information gaps in the Weather Service tropical cyclone products. And as you're thinking about that, I wanted to thank Eleanor Lutu-McMore at the American Samoa WFO and Landon Idlet at the WFO Guam for their help, as well as some graphics credits for the folks that you see there. So thank you very much.
Thank you, Jessica.